Welcome Honors Algebra 2 and Algebra 2 students. Mrs. Fallon here. We are on Unit 7, which is a unit starting out about rational functions. And so this first section is actually pretty basic, but it's just kind of an introductory section. And then we're going to get into some really kind of crazy looking graphs this unit with lots of restrictions and lots of asymptotes and all kinds of fun things. So hopefully you'll find this unit. This is kind of our last kind of real heavy algebra unit in honors, and I know regular algebra 2 is kind of doing it in different order. So hopefully you find, again, kind of similar with the trig unit. If you find yourself in a situation where you are feeling lost, I encourage you to kind of ask for questions along the way. All right, so let's go ahead and get started. So the first one I just want to talk about is what does it mean to have, so we're going to talk about two different things called direct variation and inverse variation. So direct variation is actually something you guys have already learned, probably in Algebra 1. And if you remember, it just is kind of like your basic linear equation. So for example, y varies, so a varies directly with y and x. So y equals a times x. You could also substitute or solve this equation for a and say that a is equal to y over x. And so this is just means the variation, like in other words, in how they are related to each other in terms of how y and x are related to each other. For example, y is equal to a multiplier times x. Inverse variation is similar, but a little bit different equation. So inverse variation is y equals a over x instead of y equals a times x. So this was direct variation, so we're just going to kind of remember that one from Algebra 1. And then inverse variation is a little bit different. Like I said, it is y equals a being divided by x. So another way of kind of writing this, if you want to think of it in terms of just what is a equal, you could think of it as x times y. So kind of like how we did a is y divided by x, over here a is x times y. So it's, again, that's another way of how variables are related to each other in an inverse situation as opposed to a direct situation. The constant of variation just means the a value. So that's what you notice kind of that multiplier or whatever in your equation. So a is your constant of variation, and it varies inversely. So obviously, if we're talking about inverse variation, it varies inversely with x. So you might hear in some of the directions something like, a varies inversely, and that's how you know you're using inverse variation, or if it's a direct variation, that's how you know you're using this scenario. So let's do a couple examples just to kind of get an idea of what we're going to be expected to do with some of this. So first and foremost, let's say I give you a few scenarios. So like if I tell you x, y equals 17. And so the directions will say something like, do these values vary inversely? Do they vary directly? Or do they have a no or neither kind of a relationship? So if I have y times x equals 17, so you could kind of revert it back up to here and notice that you can say, oh, well, that kind of follows that same format. Your constant is equal to your variables multiplied together. You could also solve this equation for y if you want to get it in that form, and notice that you have the constant, so y and x is on the denominator. It follows that scenario. So you would say this is an inverse variation. So the other thing is, if you're writing the equation of the inverse variation, you generally write it as y equals. So you might see that kind of a requirement if you're looking to look for the equation for that particular problem. All right, let's look at another example. So this one would be y equals x plus 29. So if you notice in this one, again, what we're looking at is the relationship between y and x. For it to be inverse, your constant has to equal y and x being multiplied together, or you can think of it as y is equal to a over x, or your constant over x. Direct variation, similarly, y has to be equal to a times x, or a has to equal y over x. In this case, we have no scenario in which we're adding a constant. So this is what we call a linear relationship, right? So this is a neither scenario. It's not direct variation, nor is it inverse variation. Let's do the last example. I'll give you another one. Y over 10 equals x. So again, be careful here that you're looking at this in the right way. So you're looking at the relationship between y and x. So a lot of times what I do is I solve the equation for y to see what format it's in. So for example, if I solved this equation for y, I would multiply 10 by both sides. So I'd get y to equal 10x. Well, y equals, excuse me, y equals 10x is this scenario here where you have y equals a constant times a variable x. So this is what we call our direct variation. And then this would be your equation for your direct variation. Let's do one more example. I'm going to grab a separate sheet of paper. I'm just going to kind of write in a bonus example, if you will. So the variables, I'm just going to write this down. You can follow it along if you want, or you can write it down if you want. Doesn't really matter. The variables x and y vary inversely, and y equals 8 when x equals 4. So it'll say something like, write an equation and find y when x equals negative 16. So I wanted to give you one example of this. So, all right, so let's take this scenario. So what we're looking at, if it says it varies inversely, so x and y vary inversely. So what I would do is start with my inverse equation. So y equals a over x. And it says y is equal to 8 when x is equal to 4. So what you are doing here, in order for us to write, when it asks you to write an equation, you want to write this equation here. It's kind of like writing like an equation in slope-intercept form, or y equals mx plus b form, right? You have to find your slope, you have to find your y-intercept, and then you plug it into your equation. Or even like a quadratic where we had to find a, b, and c. So our goal here is to use this information to solve for our constant term. And so ultimately our equation needs to be something like y equals some number over x. So what we're doing here is solving for that value a. So I would multiply both sides by 4 and I would get a to equal 32. So I know that my equation, so the part that says write an equation, is y equals 32 over x. And then they want us to find y when x is negative 16. So now what I'm going to do is plug in negative 16 for x and then simplify and find y. So this is what they're asking to do. I feel like those directions are a little bit confusing, which is why I wanted to go over that. So that's what they're asking you to do there. All right, let's move ahead to page 193, 193 of your student journals. All right, so this is like the extra practice, okay? So this is, again, similar to what we were just doing. So they're asking you to kind of talk about whether or not it shows direct, inverse, or neither. If you feel like you have a pretty good understanding of what we talked about in that last example, go ahead and try this on your own, pause the video, and see what you get. And then I'll go over answers. If you need a little bit more practice, then I'm going to do a few of these with you and see how it works. All right, so number one, again, what I would start with is by solving your equation for y. So I get 1 over 3x. So again, what you're looking for is y equals a value divided by x. In this case, it would have to be an inverse relationship, because you can rewrite this as like y equals negative 3 to the negative 1 over x, or basically what you're looking at is some variable being divided by x, and that's kind of, or some constant being divided by x. So this is inverse. For number 2, I have a constant over x equals y, so that one's already kind of in the right format, so that one's an inverse. This one would be neither because we don't have any kind of relationships in which they are adding 11 or adding any constant. This one, if I subtracted x from both sides, again, what you'll notice is that you have kind of a linear relationship. And again, we don't have any direct, this is not inverse or direct, so this would be neither. So for number 5, this is a constant multiplied by x equals y. So it follows that format of y equals ax as opposed to y equals a over x. So this is your direct variation as opposed to your inverse variation. Number 6, if I solved this for y, I would get y to equal 1/8 x minus 1/8. So I would have kind of that scenario. Again, you notice that's more of a linear y equals mx plus b. This is going to be a neither. So this one is y equals x over 7. So again, be careful here. You can rewrite this as 1/7 x. So this is that direct variation because you have a constant times x. So for this one, I would get divide both sides by 6x and you get 0. So y equals 0 is just a horizontal line. And so we're going to call that neither. And then for number 9, I'm going to solve for y. So I get y to equal, I get y to equal 9x. So again, that's a y equals a constant times x is a direct variation. All right, let's go down to some of these tables down here, which gets a little bit trickier. So what you're looking for here, when you're trying to determine if a table is direct variation or neither, it's easier to look at, remember how we talked about like a equals y over x for a direct variation and a equals x times y. So this was direct and this was inverse. So what we're looking at here is what happens with the constant term. And so when you're looking at a table to try to determine whether one is representing direct variation or neither or inverse variation, you want to look at that constant term. So what I do is I kind of look at, I'm going to add a couple extra columns to my table. So I'm going to add, just going to add this in here. So I'm going to add in x times y and x and then y divided by x. So I can see if we have any of these that are constant. In order for this to be a direct variation, y divided by x would need to be a constant term. In other words, the same number. In order for this to be an indirect variation, you would need to have x times y to be a constant term. So let's do this. So x times y, 2 times 4 is 8. 4 times 16 is 64. 6 times 36 is 216. 8 times 64 is 512. And then 10 times 100 is 1,000. Obviously, those are not the same number, and therefore this is not inverse variation. Now let's do y divided by x. So 4 divided by 2 is 2. 16 divided by 4 is 4. 36 divided by 6. 64 divided by 8. And then 100 divided by 10. So because neither of these are constant, like in other words, the constant term, the relationship between y over x or x times y is not constant, this would represent a neither scenario. So then we do the same thing for the next one. So I'm going to do x times y and y divided by x. So I get 5, 5, 5, 5, 5. Okay, good sign. Those are all the same number. Y divided by x. 5 divided by 1 is 5. Y divided by x, I get 1/5. So I'm going to stop here. Number one, because I don't need to go through the whole rest. If they're not the same, I don't need to fill out the rest. So what this tells me is that when x times y is a constant scenario, this gives me an inverse relationship. So those x and y vary inversely. All right, last one. If you want to try this one on your own, you're welcome to do so and pause the video and see if you get the right answer. So x times y, y divided by x. So 2 times 0.5 is 1. 5 times 1.25 is 6.25. So I'm going to stop there because, again, they're not the same. Y divided by x, a half divided by 2 is a fourth. Or if you'd rather write it as a decimal, you can write it as 0.25. 1.25 divided by 5 is 0.25. So far we're doing well. So let's keep going. 2.1 divided by 8.4 gives me, you guessed it, 0.25. 3 divided by 12 gives me a fourth, and so does the last one. So because our y divided by x varies, or is a constant variation, we know this is direct. All right, let's kind of move on. Let's look at page 194. So I'm on the next page. All right, so this was kind of going back to that other example I was telling you about where it talks about the variables x and y vary inversely, and then it asks you to write an equation that relates x and y, and then find y when x is 5. So I'm going to do a couple of these, and then I'm going to have you guys kind of pause the video, try a couple on your own, and then check to see that you have the right answers. All right, so for number 13, again, you're looking for variation or inverse variation, so that's y equals a over x. You're going to use this information here to be able to determine what a is. So if I'm going to plug 2 in for y and 2 in for x, so if I solved, I'm going to multiply both sides by 2, I get a to equal 4. All right, with a equaling 4, let's go ahead and write our equation. So our equation would be y equals 4 over x. This is the equation I'm looking for, okay? So that's this part, write an equation. Now tell me the value of y when x is 5. Well, when x is 5, y is 4/5. Let's do another one. Let's do number 15. So 15, same deal. We start with your inverse variation relationship. Let's plug in x and y. I'm going to go ahead and cross multiply here. So I get 20a equals 140. So I get a to equal 7. I'm going to write my equation. This is my equation. Now I'm going to plug 5 in for x, and I get 7/5. Go ahead and try 14 and 16 right now and see what you guys get. Go ahead and pause the video, unpause when you're done to check your answers. All right, welcome back. What I got for this one, I did y equals a over x. So I did 3 equals a over 6, and so a equaled 18. So my equation was y equals 18 over x, and y equals 18/5. For this one, I did 3/2 equals a over 10/9. So it looks a little weird. So I did, I kind of reduced the right side of my equation. So dividing by 10/9 is the same thing as multiplying by 9/10. Whoops. So this would be 9a over 10. So if I cross multiplied, I'd get 18a equals 30. Or in other words, a equals, let's see here, 10/6, which could be reduced to 5/3. So my equation would be y equals 5/3 over x. So be careful here. So how we're going to write this one, this one's a little tricky. So I don't want you to leave it this because that looks weird. If I'm dividing 5/3 divided by x is the same thing as multiplying by 1 over x. So you need to write your equation as y equals 5 divided by 3x. And then to plug 5 in for x, I would get y equals 5 over 15, which is 1/3. So that was a tricky one, mostly because of all the fractions within a fraction, but you guys can handle that. We're going to be doing a lot more of that in this unit. All right, let's talk about a couple story problems, and then we'll be kind of done with this one. It says the temperature is held at a constant The volume of gas inversely proportionately to the pressure of the gas in its container. A pressure of 32 pounds per square inch results in a volume of 20 cubic feet. What is the pressure if the volume becomes 10 cubic feet? So we have volume and pressure, right? So we're talking about how they vary inversely. So the reason I knew that was I said inversely proportionally. Inversely proportional is what the key word here is. So when I write my equation, I'm going to go ahead and using my information, I am going to write my equation like I did above. So I'm going to plug in my values for x and y, and I'm going to solve for a. So I have my my 20 in for my, so 20 is representing the volume, and then I'm going to plug in 32, which is for the pressure. So I get A to equal 640. Okay.
Francesca Murray.
So your equation would be 640 over x. And then what we're going to do now is now that we have the equation, it just says, what is the pressure if the volume becomes 10 cubic feet? So all I'm going to do here is plug 10 in for my volume and solve for x. And so I get 10x equals 640. I get x to equal 64 pounds per square inch. All right, last but not least, number 18, kind of same deal, says the time, t in days, it takes to harvest a field varies inversely, so again, keywords here, with the number n of farm workers. A farmer can harvest his crops in 20 days with 7 farm workers. So number varies inversely, so we're talking about the number of fields varies inversely with workers. So the days it takes to harvest a field. So days and farm workers. So days and farmers are kind of my two variables. A farmer can harvest his crop in 20 days with 7 farm workers. How long will it take to harvest the crop if he hires 10 farm workers? All right, so we're talking about inverse variations. Let's start here. We're going to find our equation. So we know we have 20 days, so that's our, and it varies inversely with the number of workers, which was 7. So that means our constant variation is 140. So let's write our equation as 140 over x. So we have our equation now. We want to know how long will it take, or how long will it take to harvest crop if he hires 10 farm workers. So workers is x, so we're going to plug in 10 over here. And if I divide, I get 14, since we're talking about a unit of time, we're talking about 14 days. All right, practice on big ideas. Come to class with any questions. Good luck. That's all for now.